Welcome back, everyone. This video, I'm actually going to have to step through the code a little bit. I tried not to get into the details of the code base for this video, but I think it's probably the easiest way to explain the actual trading algorithm, the custom algorithm that we've developed, which is kind of the heart of this effort. And maybe to step back a little bit further, if you remember from the first video, we had this Docker file which created the Docker image we passed in the SageMaker. And just to kind of orient us, our code and how it's used in SageMaker. So one of the things that we pass into it is this environment variable, or we set the environment variable here, and we put it to train.py. And this is what tells SageMaker to go and run. It's our entry point into our code base. And actually, if you look at in the build here, when we went through, you can actually see in the log that gets spit out, or the standard out, you can see they're calling Python -m, which is the module, train.py, and then it's passing in a single hyperparameter. And that hyperparameter comes from right here, right? Hyperparameter start day, and then we give it a value of 290. So start day 290. And so we look at our code. What we have to start with is something called train.py, and that's it here. And so it just sits on inside the source directory, which is going to be right what it sees, right? It gets passed into the image. And it starts off by parsing a large number of command line arguments. So the one that we showed there this then was start day, and we gave it a value of 2900. However, the default value is 504. So all the others, if we do not pass in, it gets the default. So you can see this block in particular are values that we'll probably be using when we do our hyperparameter tuning. You could actually pick anything, but these are the ones that are kind of set up for hyperparameter tuning. And the others are more about running the code. Another hyperparameter that's worth noting here is this price's name. So right now we've created this synthetic pricing, and this is the name of the file that we passed in. However, in one of the following videos, we're actually going to do this with real pricing. And so all we need to do, we don't need to do any change to the code. We simply run it again. But in here, when we give hyperparameters, we have to say that price's name, and we have to give it the name of the actual real data file. And so it's as simple as that as we go. So again, I want to kind of step through this. So there's a lot of hyperparameter tuning. And actually, before I jump in there, just to, again, to keep us oriented as a good reference, if we go back to the original repo that we did last year, you'll see there's a couple reports in here. And one, report 2. And if you open that up and go to page 6, it kind of gives a high-level view of the reinforcement, the classic reinforcement learning algorithm that comes from literally right out of the textbook, right? And as you can see the code, and you keep this in mind, you can see it really follows this feedback loop really well. So the first thing it has to do is set up the portfolio environment. This env is the environment. And so that's literally this box here. So when we step to it, we can see we start up, and it initializes it. And this environment, of course, is the financial market environment that we want to interact with. And when we look through, one of the first things during its initialization it's going to do is just read the price history, right? The prices that we pointed to. And the price history is really going to be used to generate rewards. So prices is all about generation of the rewards. Whereas we have the signals, which it reads in here, and the signals is all about, the state of the environment as we go through. So it loads everything up. It does a little bit of reorganization here of the signals because, again, remember how we were going to segregate all of our signals into groups, for each asset. So in our particular one, we have 10 assets and 6 signals per asset. So it just goes in and reorganizes it so that when it's learning, it can just go in and grab first batch of 6. It can basically split the signals up into 10 batches and then feed it into all of the mini models that we're generating. So that's the environment. And the main thing the environment does over and over again is stepping, right? And so if you really kind of compare this to the environment here, right? What it does, it takes in the actions, right? It takes in the actions into the environment. It's going to calculate, based on our current portfolio, and it also looks at, the gain that is going to be, that we know from the environment because we passed in the pricing, right? It can calculate the reward. And it can calculate what our future portfolio value will be based on not only, we chose these particular assets and these assets went up or down, but also we have a loss function. So it subtracts out a loss here because there's some friction related to actually doing the trade itself. And that'll impact your portfolio value and the reward that comes out here. So it calculates the reward, which it passes back, And it also calculates the state. And effectively, all you're doing is not really calculating the state. All it's doing is extracting from those signals that we pass in the window on the states. And it's a window length because for time, t is equal to 0, or t, I should say, or t0 in this particular case. We're not only just going to look at the signals at that time, but also if the window length is 10, the previous 10 days, right? So we're always kind of looking at this window in time, and that's our state. So our state is not just 10 assets times 6 signals, 60, but it's 60 times the window length. It's kind of a nice big square block of data that it's pulling out. And so when it has that, it just returns the state and the reward here, and then the agent then has to take that information and learn from it to decide what the next action is. So if we go back in, that's the environment that's defined. The next thing it has to create, and this is all just during the initialization, of course, is to determine the agent. And one of the nice things here is very separate. So if you wanted to in the future put in a different agent, this is kind of where you would insert it here. And all the agents need to have the same sort of thing where it reads the rewards and states, passes out the next set of actions. So we go into the agent. And this one is a DDBG, which is a deep deterministic policy gradient agent. This is details. I'm not going to go through the code here because I think it's beyond the scope of this particular video. But basically what you kind of need to know for this particular reinforcement learning agent, we have an actor which actually decides what to do. And then we have another model, which is the critic, that says, well, how well did they do? So that's kind of these two things work together all the time. One assessing how well it did, and one saying what I should do. And each of those are actually the artificial neural net that we were going to build. And actually internally we have 4, because we have 2. We have a local and target, but again, that's more of a detail. But we have 2 actors, 2 critics running to come together to make this a reinforcement learning agent. And each of those, the big difference, of course, between the actor and the critic is the actor just sees the state. And then the inputs to the critic is not just the state, but also the actions that the actor made. So it takes those 2 things to determine how well it did and provide the feedback and learning to the system. So that is your agent. Again, a little bit out of scope of here, but it's good to kind of see where that code is. And then the agents themselves, of course, calling 4 different instances of these models. And this is the actor model and the critic models. And then what really we get into, which is I think the real difference between this algorithm and others, is the training algorithm itself. So now, once you have everything initialized, we start to train. When we start to train, the very first thing it's going to do is do some offline training. Because of course, if you have 12 years of history, for instance, and you say, I'm going to start the trading after year 2. So you've got 2 years, really minus a day, because you don't want to train with today. But you've got that previous history to go and learn on and train your agent. And that's what this is, offline training. It goes in, and let's jump to the offline training. What it's going to do is get in here, it determines a target, because we know in this particular case, it's another command line argument. The default is 5%. It's got to figure out what that target would be, for just a number of days, because we're going to trade and use that target over a set number of days per epoch. And an epoch is kind of a training iteration. So you're going to go in here and you're going to say, let's say this days per epoch is 40 days, right? 2 months. So for each epoch, you're going to trade for 40 days and see how well the agent did, right? And it sees how well it did based on the portfolio value divided by the market value. And then we say, okay, we've got in there, we've done our training. If it's better over the last 100 days, right? It does this little queue. So it's got to have 10 epochs to start. So when you get in, you can't just, because you might get lucky on an epoch, especially at the beginning when things are a little bit random, and you are starting at any time in those 2-year period, right? So you might get a particular time where you could do well. So we want to get an average, and you want to have at least 10 epochs under your belt before you can actually start using that average, and that's what it's doing. And then the average is over this epoch window, which could be the last, up to 100 of the last epochs that you go through. If it's greater, if our how well we're doing is better than the target, then it kicks out of the offline training. If not, it stays here. So if a model is doing poorly, it stays in the offline training longer than if it does really well. And let's just step through the actual trading here, which is the same. We'll see this again once we go to the day-to-day. But effectively, you come in and you have a state. It starts off at the epoch. It has to pick like a day to start with, right? And it's a random choice. So it randomly picks any day starting from, day 0 to this max start day. And the max start day, has to be before, and actually not only just before today, but minus again the number of days in the epoch, because you can never reach today when you're doing the training, because we don't want to look forward past today. So you got to be well into the past, but it does do a weighting. So it's not just you can pick any day in the past, it weights it so that the days closer to today has a higher probability of being picked than the days far in the future. This is especially important if you got 20 years of history behind you. Something that happened 20 years ago is not as important as something that happened yesterday. So there's this weighting. It still has a probability of getting something a long time ago, but it's less chance of getting that. And the strength of that probability function is yet again another argument that you could train, or you could tune in your hyperparameter tuning. So once you pick the start day, it comes through, it initializes it with that particular day, so it's got the state of that particular day, right? And it goes in, got the state, it gets passed to the agent, right? Here's the agent. The agent decides, based on that state, I'm going to take these actions. That's the actions. Then these actions get passed to the environment, right? And the environment steps. And when it steps, it determines the rewards based on the actions and the current state. And the next state, as we say, was just simply the next iteration of the set of signals that we have. And so now you've got the next state and the reward. And this information gets passed back into the agent. And this is kind of where the learning happens, right? So the agent sees, that was the previous state. This is the state now. This is the actions I took, and this is the reward I got. And so it can do a little bit of learning. So this is kind of where the learning occurs. There's obviously lots of details when I say that, but that's the main step where the learning occurs. And then we just keep stepping. And we just step through this over and over again. Every single iteration, we learn a little bit. And we keep doing this until the agent can get to a point where it's beating the target consistently, which is the mean over this epoch. And once it does that, we get to go back and actually start in. And here we just start stepping through, our start day, which, if we say we're starting at year 2, it just picks the start day, and then it's going to go till the end of the number of days. So however many days is in your environment that you give, which is the set of signals that you provided it. We just have to start, of course. We have to pick that portfolio, the value of the portfolio on that day, the market value on that day, and then the weights that we had. And the reason why we do that is a little further we get popped off into our online training, so you kind of have to reset here at the start. And then just like we mentioned before, we have the state. The agent reads that, determines the actions. Based on the actions, we step the environment to get the rewards in the next state. Then we do a little bit of learning. So every single day, there's a little bit of learning that happens. And then we keep walking forward. And the real kind of magic here is that as we keep going and we start trading, so this is like real life. Every day you'll be doing this, right? You do this trade and you do the learning every single day. But you're going to reassess. So, is my alpha over the last 5 days greater than the target that I've set for it? So, 5% per year, right? So we calculate that. We say, you know what? My alpha is greater than my target. Therefore, I don't need to kick off any online training. My model is doing well. If it's not broken, don't fix it. Let's just keep going. And so that we just keep on moving through. However, if you do that and you see that we're no longer being able to meet our target, it kicks off offline training. So this would be, trying to replicate what you would do in real life. This day that we're stepping through is a real day in the life, right? And so you assess how well is the model doing. If the model is doing excellent, don't mess with it. But if you check and you say, over the last 5 days, our alpha is not as high as we want, let's do some offline training. It just kicks off that offline training exactly like here. It trains until it consistently can beat the market again, and then it'll just go to the next day. And that's kind of why you need this reset, because you might get in here, so you have to reset it. And this is really the heart of our algorithm. It just constantly keeps going through this every single day, really trying to replicate what you would do in real life, where every day you get another set of market data, you step it, you learn on that day, but then you're constantly kind of assessing how well the model is doing over the last 5 days or whatever it may be. If it's not doing well, let's go and do some offline training. And so that's how it steps through. So this was kind of, again, very quick, but I think an overview of the algorithm and the real heart of the algorithm, which is really here. Kind of some references to the DBG and the model. But again, that's something for you to dig into if you wish. I think the thing that's different than most reinforcement learning algorithms is this little bit of logic you see on the screen now. And it's really trying to replicate what you do in real life. Sometimes you see where they would train for 10 years and then see how well the model will do for the next 2. That's not realistic. You would constantly be training. If your model wasn't performing well, you would retrain. And there's nothing wrong with that, right? Because you're not going to train with future data, but the previous history. And that's why you're doing this offline training. Similarly, I've seen papers where they will take randomly picked days over 10 years and then say, okay, it's trained. Now let's go back and let it play through the 10 years to see how well it would do. That also isn't fair because you've been exposed to future data, right? So of course your model will do well. It knows how it's going to do. So here, this is a very adaptive algorithm that I think would replicate trading in the real world. So with that, in our next video, we will go through SageMaker, where we're going to actually see how well it does with the synthetic data. And if it does well in the synthetic data, then we're going to go through and try again with the actual pricing, which would be replicating, how well this process would work with real pricing history. So with that, thanks, and I'll see you in the next video.